Hello, beautiful people, and welcome. In today's video, we are going through the Chapter 6 quiz from Integrated Math 1. If you are in my class, make sure that you are on the correct version as there are multiple versions of this quiz. Let's go ahead and get started. Question number 1, identify the following exponential functions as exponential growth, exponential decay, or neither. When you are asked for growth, decay, or neither, you're going to take a look at this B value, and this B value is going to then take a look at your A value. If your A value is negative, that will mean an automatic answer of neither. Again, you see this negative, that means your answer is going to be a neither. That means there has been a reflection across the x-axis, making this not a growth and not an exponential decay. If we take a look at our B value here and our A value, we notice that the A value is positive. Here, we take a look at the B value and our A value is technically missing. So if it's missing, our A value is 1. So this is still a positive value. When you have your A value positive or your function positive, then your growth, exponential growth or exponential decay will depend on your B value. This is your B value, and if your B is greater than 1, you have exponential growth. And if your B value is between 0 and 1, less than 1, a fraction, then you have decay, exponential decay. Question number 2, identify the asymptote of the following functions. So an asymptote is your K value, and sometimes your K value is missing. Right? If you have a missing K value, that means your K value is 0. Now notice how I wrote the answer. The answer is y equals 0. You have to have it in the correct format. So all of our asymptotes are going to be identified like an equation of a line. And we're going to say y equals and find our K value. For our next question, it is asking us to describe the transformation. So there's different things that we have to describe. We have the negative. We have our A value. So notice how I am highlighting the negative and the A value separately. That's because they mean different things. We have this negative 1 that means something, and we also have this negative 4 that means something. And then this B value that we had, we will take a look at our A value to determine if this is exponential growth, decay, or neither. So let's go ahead. So this negative represents a reflection across the x-axis. The green 3, notice that our A value is greater than 1. Just the 3, not the negative. I'm not saying negative 3 is bigger than 1. I'm saying 3 is bigger than 1, which means we have a vertical stretch by 3. Because we have a exponential decay, but we do have a negative, that means we have neither growth nor decay. And that's because this happens. That's because a reflection across the x-axis happens. Here we have our h value. It's opposite of what we see. So we see a negative 1. That means we have a positive 1, and we go to the right 1. So this is what the transformation is, right 1. And then here we have a K value of negative 4. So we go down 4. Moving on to question number 4, does the table represent an exponential function? State your reasoning. So for these ones, these are asking for, is there a common ratio? I'm going to go ahead and push both tables off to the side, and I'm just going to rewrite it. The reason I choose to rewrite it because then it's easier to see which one is your right value and which one is your left value. We have 10 over 50. We have 2 over 10. We have 0.4 over 2. Now, if this gives us a common ratio, then yes, this is exponential. If it does not give us a common ratio, then no, this is not exponential. Let's see if I can find a non-glared spot here. So let's go ahead and start with our first fraction of 10 over 50. Again, decimals are not allowed. So second PRB, we get 1/5. 2 divided by 10, we get 1/5. Promising. And do our last one, 1/5. So that means, yes, there is a common ratio, and so yes, exponential. Now we have to state our reasoning, yes, exponential. How do we know? Because our common ratio is 1/5. You don't have to write the word common ratio, you can just write R equals, that is enough. Our next one, again, let's go ahead and push this off to the side. I'm going to separate this out with a line. Here's our X, here's our Y. And here we have 1, 2, 3, 4. And we have 17, 51, 17, 51, 153, and 459. Again, right over left, right over left, and right over left. I will say these numbers are giving me a little bit of anxiety because things like 51 and 17, I don't know if that's going to simplify, but we're going to double check. And it simplifies to a perfect 3. I did not expect that. So happy accidents here. 3. Next we have 153 divided by 51. 3. Perfect. These are making me happy. And 3. Again, is this exponential? Yes, it is exponential. How do we know it's exponential? We have a common ratio of 3. Moving on to the next question on the back side. For this question, we are asking you not to use a calculator, so graph the following function. Again, this is without a calculator. So the first thing you're going to do is copy down the function, but anytime you see x, you're going to write this number instead. So I have 1/3. I see an x, so I'm going to write -3 plus 1. 1/3 -2 plus 1. 1/3 -1 plus 1. 1/3 0 plus 1. 1/3 1 plus 1. So again, where are these numbers coming from? This -3 came from -3. This -2 came from -2, -1, 0, 1. And again, this is because we have an x right there. And then the rest of the function is this 1/3 plus 1. 1/3 plus 1. 1/3 plus 1. So all we did is we replaced the x with an x value. So we are asking you to do this without a calculator, and the reason is we want to test for 2 things. Can you show us how to deal with a negative in the exponent spot, and do you know what exponents are? So for us, we're going to continue. We got 1/3. -3 plus 1 is a -2. 1/3 negative 1/3. Let me fix that. -2 plus 1 is a -1. -1 plus 1 is 0. 0 plus 1 is 1. And we got 1 plus 1 is 2. Okay, so one of the first things we want to do is test, can you show us that you understand negative exponents? So a negative exponent means you flip the base. So what we're going to do is we're going to take this negative and we're going to change this to a 3 over 1. We're going to take this negative and change this to 3 over 1. Here, nothing else for us to do. These are not negative. Next, we ask you to show us, do you understand what exponents are? So here we have 3 times 3. You can do 3 over 1, 3 over, 1. And the reason I'm writing this twice is because I have an exponent of 2. Here I'm writing this 1 time. Anything to the 0 power is 1. 1/3 once. I'm just going to write it once. 1/3 to the exponent of 2 means I got 1/3 times 1/3. Here we got 3 times 3 is 9 over 1, which is just 9. Here we just have 3 over 1, or divided by 1. Here we just have 1. Here we just have 1/3. And here I have 1 times 1 is 1. 3 times 3 is 9. Now, what is the asymptote? Our asymptote is our k value. So I'm going to go back up here. This is our k value. If you have a missing k, then you have an asymptote of 0. For the domain, you don't really need to know what the function is per se. If it is exponential, it will always have the same domain, and that domain is from negative infinity to positive infinity. This is always the same. For your range is dependent on your asymptote. So let's go ahead and draw out our asymptote at 0. Make sure when you draw your asymptote, it is a dotted line and extends past what is provided for you, so that way we can actually see it. Let's graph our points. We got a negative 3, comma 9, a negative 2, comma 3, a negative 1, comma 1, a 0 and 1/3, and a 1, comma 1/9. So let's start with a negative 3 and 9. Oops, negative 3 and 9. Negative 2 and 3. Negative 1 and 1. 0 and 1/3, and you can see it's going to get smaller, closer to our asymptote. Now, whenever you draw this, please make sure not to touch the asymptote and not to go back up. It's never going to go back up. It's not a parabola. It will get exponentially closer and closer to your asymptote. So let's talk about the range. I almost forgot. For your range, you're going to take a look at what we are approaching. Now, we are approaching 0. This is our smallest value. And then you can see I even have an arrow. That means that I'm going to be increasing on my y value. So that means my smallest value is 0. And then I'm going to be having y values that are going up. So we're taking a look at our y values for our range. Now this is a exponential decaying function because we are going downhill. Go and flip our page over. Again, without a calculator, we are asking you to do this without a calculator. You're going to copy down the function. Anytime you see an x, you're going to put in these numbers. So for us, we have 4 to the power of negative 2 minus 3. Make that 3 a little bit bigger, so that way you can see that it's not part of the exponent. So we got 4 to the power of 1 minus 3, 4 squared minus 3. Again, the question is, can you do this without the use of a calculator? Can you show us two things? Do you know how to deal with negative exponents, and do you know what exponents are? So the first step is to show us that you know what the negative does to a base. The negative flips the base. So my 4 becomes a 1/4. My 4 becomes a 1/4. Now I'm only doing this to these two because those are the only ones with negative exponents. The following one, we're asking you, do you know your exponential properties? And do you know what an exponent means? Now I'm making this in a different color because I want to show you that anything to the power of 0 is 1. Now we have 4 squared, which is 4 times 4. And then again here, we have to expand. We have 1/4 times 1/4 minus 3. We have 1/4 once minus 3. And then here we have 1 minus 3, which is a negative 2. We got 4 minus 3, which is a positive 1. We got 4 times 4, which is 16, minus 3. And we got 13. Now we do have to deal with these, and I am asking you to do this without a calculator. 4 times 4 is 16, so I'm asking you for 16 minus 3, and I'm asking you for 1/4 minus 3. I'm going to shift this a little bit higher so you guys can see. I'm going to use this space for work, and I'm going to separate this out. First one we have is 1/16 minus 3. I'm going to write 3 as 3 over 1. We do need common denominators. That means I'm going to multiply top and bottom by 16. 1 over 16 minus, I am cheating a little bit and doing 16 times 3 on a calculator, and that gives me 48. 1 minus 48 is a negative 47, and we keep the denominator. So here we have negative 47 sixteenths. For our next one, we have 1/4 minus 3 over 1. Again, common denominators, multiplying top and bottom by 4. We got 1/4 minus 12/4. We get 1 minus 12, negative 11/4. Bring that up. What is the asymptote? Let's take a look at what our k value is. Our k value is a -3, so we have y equals -3 as my asymptote. Domain, again, it doesn't matter what we have as an exponential function. We just know it's going to be from -infinity to +infinity for the domain. For the range, it is dependent on the asymptote, so we'll deal with that later. Let's start with our asymptote at -3, dotted line. Make sure you go past what is provided to you for your graph, so that way we can see it, and it has to be a dotted. Next, we're going to sketch this out. Now, some things like -47/16 is going to be difficult for you to sketch, so start with the whole numbers and then go there. So we have 0 and -2, 0, -2. Next, we have 1 and 1. Now we have 2 and 13. Now it only goes all the way up to 10, so I'm going to guesstimate, use a pencil here. I'm going to guesstimate where 2 and 10, 11, 12, maybe 13 is around here. Then we have -1, and so if we follow the pattern, we should expect our next two to be approaching the asymptote like this. So we're going to make assumptions and say there they are. Make sure you have arrows on both sides. So let's talk about range. What is the smallest value we are approaching? We are approaching a -3, and then we are going all the way up to infinity positive. Next question is asking us to determine whether the table represents an exponential growth, exponential decay, or neither. Now, some of you did lose points here on the quiz because you only told me yes, it is exponential, or no, it is not exponential. It's actually not asking you that. It's asking you, is it a growth, is it a decay, or is it a neither? Again, you're going to start with your common ratio. So right divided by left, right divided by left, right divided by left. See what that is? We got 16 over 64. Decimals are not allowed. We get a 1/4. 4 over 16. Decimals are not allowed. I get a 1/4. And here, there's nothing for us to do. You can type it into the calculator, but again, it's just 1/4. This gives me a common ratio 1/4. Now, what it's asking you, is it a growth, or is it a decay, or is it a neither? Because we do have a common ratio, then yes, it is exponential. But because this common ratio, this 1/4, is between, you can almost think about it as your base. It's between 1 and 0. It's a fraction that's positive. And it's less than 1. This is an exponential decay. Okay, let's do the next one. 11 over 4, 18 over 11, 25 over 18. And again, these are giving me a little bit of anxiety because I don't think we can simplify these. So I get 2 and 3/4. We can't have that. We have to convert. 4 times 2 is 8, 9, 10, 11. Yeah, these fractions stays the same. 11 and 18, they don't get along. We can't simplify that. And then 25 and 18 also don't simplify. So we end up having the original fractions that we have, and the reason is we can't simplify these fractions. So these are not common, no common ratio. So it is asking you, is this exponential growth, decay, or neither? So it's not asking you if it's exponential, it's asking you, is it exponential growth, exponential decay, or neither? Since there is no common ratio, it is a neither. You can also say, I need this word neither, but not exponential. Okay, moving on. Almost done here. Question number 8. A pond has 350 fish. The population decreases. Keyword here is decreasing. That means we have growth versus decay, and this is decay. And we are decreasing by 3%. 3% needs to be converted into a decimal of 0.03. This is our rate. Okay, we're going to have a rate of 0.03. Write a function to represent the number of fish after X number of days. So we're going to start with y equals. We have an original amount of 350, 1 minus, since we are decaying, our rate as a decimal 0.03 to the power of x. Now you have a choice. Some of you, most of you, kept your answers like this in this unsimplified format, but technically you do want to simplify your answer. 1 minus 0.03. And for your answer, you want to write y equals 350, 0.97, and then x. I did accept both, but this is more correct. Find the population after 7 days. So again, depending on which equation you use, let's go ahead and use this one. We're going to take the equation that you have created, and you're going to plug in 7 as your x. Now you're going to type that into the calculator exactly how you see it. That's a 3. 350, open 0.97, caret 7. And again, since we're talking about fish, you can't have just a random tail floating around. We're going to take a look here at the 7. That means we round up our 2, so we have 283 fish. Now, if you wanted to use your other equation of 350, open 1 minus 0.03, close it, caret 7, it still will give you the same answer. Emma has $1,500 in her savings account. Her balance will increase, again, so growth formula, and it's going to increase by 10% each month. Convert that to a decimal. So 10% means we're going to shift 0.10 as our rate. Write a function to represent how much money Emma will have in her savings account after X months. So they don't want us using t, they want us using x. So let's write this growth equation. Y equals starting amount is 1,500. Open 1 plus because we are increasing our value. 0.10 is our rate, and they want us to use x as our months. Now again, some of you, most of you kept your answers like this. That's okay, but it is more correct to simplify this and then write your answer without having the addition on the inside. So this is 1.1 to the power of x. If no other deposits or withdrawals are made, how much money will she have in 1 year? So this is a trick question, and I want to focus on the words that are given. They want x in months, and they want time in years. So because we have our x in months, our rate is monthly based, right? Because it's each month. We have to convert 1 year into months. That means we have 12 months. So when we take our formula of y equals $1,500 times 1.1, this is our growth rate, we want to put that 12 instead of a 1. Okay, 12 because we have a monthly rate. So we have 1,500, open 1.1, close it, caret 12. And again, this is money, so money needs to be rounded to 2 decimal places, and we want the dollar sign. $4,707.64. We're looking at this 2, so we keep the 4. Let me show you. There it is. Again, if this 2 was 5, 6, 7, 8, then means we would round up. Moving on to our last question, write a function that represents the balance. We have $2,000 deposit that earns 5%, 5% annual interest rate. And here's a keyword here to know which formula to use. That's compounded monthly. We did not have this word in any other word problems. That means that this compounding is a special formula called a compound formula. This monthly represents your n value, and it tells us how many times things are calculated in 1 year. Your 5% needs to be converted into a decimal, and we start writing our formula. Our formula is y equals our starting amount, so $2,000, times open 1 plus open. Now, in your numerator, you're going to have your rate of 0.05. In your denominator, you have your n value, which is how many compounds you're going to have. So words like semi-annually, which is twice a month, quarterly, 4. We have monthly, which is 12. Semi-annually, twice. I think I said that already. So we have double parentheses, and then for our exponent, we have our n value, which is our compounds, and then we have a t value for how many years will go by. It's a lot to write, so I'm just going to draw an arrow. This is our formula for our compounding. Now, if they want to calculate the amount after 5 years, because t is already in years, we don't have to do anything that we did here. Here, our rate was given in months, and it's asking for years. Here, our rate is in years, and we're asking for years. So you're just going to take this formula, put in 5 for your t value, and type into the calculator. Now, when you type into the calculator, make sure you have double parentheses here around this fraction, then around this fraction, and then when you do your caret with your exponent also has to be in a fraction. So lots of things to put parentheses around. Let's do it together. Let's erase this. Type this in. 2000, open, 1 plus open, 0.05 divided by 12, close it, caret, open, 12 times 5, close it, enter. Now again, what are we talking about? We're talking about money. Money needs a dollar symbol, and we need to round correctly. $2,566. If you're taking a look at, oops, did it change? Let me try it again. There it goes. 71. We're taking a look at the next number, which is a 7. That means we round that 1 up to a 2. All right, beautiful people. If you are in my class, this is required for you to retake this quiz. So after this video, go ahead and start on the required worksheet in order for you to be eligible on any retakes. Thank you so much for watching. Bye.